So welcome back. This is number 16 in my Fog of War series. This one is called Maximum Minimum Cells. So I'll just go through the rules with you first off. Cells separated by an X add to 10. There's an X there. Those two cells have to add to 10. Cells separated by a black dot and the ratio 1 to 2. It's a standard rule we've used lots. They have to be either a 1, 2, a 2, 4, 3, 6 or 4, 8 pair. Cells in cages add to the number in the top corner of the cage. So this, for example here, they have to add to 11, and numbers cannot repeat in a cage. There's standard cage rules. Arrows pointing out from the cells are maximum values, that is, larger than the 4 adjacent cells. I've made them blue for clarification. So these ones here, which are sort of a pale blue colour, have arrows which point out from the cells, and they have to be larger. Now I've written larger than the 4 adjacent cells, but these ones here only have 3 adjacent cells on, if they're on the edge, obviously. But the arrows pointing out means this one's bigger than those ones. So those are the two big ones here. Arrows pointing into cells are minimum values, that is, smaller than the 4 adjacent cells. I've made them orange for clarification. Now, I've said orange there, but they look kind of yellowy on this screen, so it might depend on what screen you're using. I made this Sudoku on a tablet, and they looked very orange on the tablet, but now they're looking yellow, so I hope that's not confusing for you, but they're obviously not the blue ones, so it's not too bad. So these ones here have the arrows pointing in anyway, and they're minimum values. So that one, for example, has to be smaller than all those 4 adjacent cells. Now, if there's a blue one out here in the middle, it would have to be larger than those 4 adjacent cells to it. Obviously, it doesn't include the corner ones because that would be a bit too much to have it larger or smaller than every single thing. It would only work with a 9 or a 1 then, wouldn't it? So that would be a bit pointless. So it just works with these 4 adjacent cells, and these ones are the larger ones, and these yellowy, orangey, whatever colour yours are, will be the smaller ones. And that's all there is to the rules. This is the first puzzle I've made with these maximum minimum ones, so I think it's turned out quite fun, and I hope you like it. There's a link in the description below if you'd like to click on that and have a go yourself. And if you have a problem, come back and check the solution and see what you need to do to continue. Alright, so I'll start off now with that one there. Has to be a 2, 4, 6 or 8, because it says that cells with a shaded square are even. I think I missed that rule at the start. I didn't go right to the top. Sorry, cells with a shaded square are even. So that one's 2, 4, 6 or 8. Now this one here has to add to 11, and those two have to add to 10. So that one's got to be a 1. These ones here, now normally you'd put a 2, 4, 3, 6 whatever pair in, but because this one has to be smaller, I'll just put in, that could be a 2, that could be a 4, that could be a 3, that could be a 6, that could be a 4, and that could be an 8. And they're the only options there. Now that one has to be bigger than that one, so that actually can't be a 2, can it? 2, if that's a 2, 3 or 4, 2 is not going to be bigger than any of them, so it can't be a 2 in the middle. What now? I don't think there's any point looking at these ones. That could be anything bigger than a 1. We don't know what that is for that one yet, and there's no way to eliminate these ones yet. So what else can we eliminate down here? We can't have a 9, 1 pair there, so a 9 has to go there. And there's a 10 cage, so you couldn't have a 9 there because that cage continues on. So you can't have a 9 in either of those spots. That one there has to be the 9. And now a 5 can't go there either on an X thing. So if the 5 was there, that would be okay. If the 5 was there, you'd have to have something bigger than a 5. So it would be, 6, 7, 8, and 5 and 6 is 11, which is too big. So the 5 can't go there. The 5 would have to go in that spot. And that gives us a 2, 3, 2, 3, or a 4, 1. I can't have a 1, 4 because of that one. So that's all for that. And now it gets a bit tricky. So we've got to see which one of these is possible depending on what we put in here. Now if we put an 8, let's say, I don't know which way would be the best way to do it. If we put an 8-2 in there, that one can't be an 8, that one can't be an 8, we'd have a 4-6 pair. And then we've used up the 2 and we've used up the 4, and we'd have 2 3s that would have to go in there. So we can't have a 2-8 pair in there. I'm going to use the 6-4 one next, because I can see that's not going to work straight away, because if you have a 4-6 and a 4-6, you're going to have 2 8s there. So that's not going to work either. So that must mean that that one has to be a 7-3 pair. In fact, we can put that in because we've used up all the other options. It's got to be a 7-3 pair. And in that case, that leaves us with a 2-4 there and a 6-8 there, which will work. So that's okay. So we'll get rid of the 3 there and the 3 there. And that's a 2-4. We can get rid of the 4 there and the 4 there. And that actually is the only way that it can work. Now, how can we eliminate those? That one, the 3. Oh, we can do it by this pair here. Can't have 2. The 6 has to go with the 3 because the 3's over there now. That can't be a 6, so that's got to be an 8, and that's got to be the 4. That's the 6, 2, and then that one's a 3. And this one here has to be less than a 6, so that has to be the 3, and that's a 7 and a 3. And that's got to be smaller than those two, so it's got to be a 1 or a 2. That's got to be smaller, so it has to be a 1. Now these two squares have to add up to 14. We could have 5, 9, and normally we could have 9, 5, but that one has to be bigger, so they can't go the other way around. And the only other thing that adds to 14 is 6, 8, and there's already a 6 there, so we can't have that. Can't have 7, 7 in the same thing. So that means that is a 5 and that is a 9. Okay, let's see what we can go in these squares. You can have 1, 2, 3, 4, 5, no, not 5, sorry, these ones here can't go in it either. 5, 6, 7, 8, 9. So that one's going to be 2, 4, 6 again, because it's the same row and the same ones there. This one will be different. We've got a 2, 3, 4, 5, 6, 7 and 8 that can go there. Now they've got to add to 14. It can't be a 2, or you'd need 12 there. It can't be a 7. There's not 2 things there that add to 7. So that has to be an 8. And then 8 and 6 is 14, so I have to get rid of the 6 and have a 2, 4 pair there. And that leaves us with a 6 and a 7, and the 6 would have to go there, and the 7 would have to go there. So that's a 4. And now where to go? That one's got to be bigger than a 4, 5, 6, so it's got to be a 7, 8 or 9. It's got to be less than a 4, it's got to be a 1, 2 or 3. This pair here now, we can have a 1, 2. We can't have a 3, 6. We can't have a 4, and therefore we can't have an 8. So it's a 1, 2 pair. That tells us that one's a 3, excuse me. And now that's a minimum. So it's got to be less than that one. So that one's got to be the 1, and that one's got to be the 2. And now this cage can be 1 from 14 to 13. So kind of 3 could have 4, 9. But that one's got to be bigger. So that's got to be 9, 4. And there's a 1 down there to get resolved. Or we can have here, we can have an 8 and a 5. Can't have a 7 and a 6 because there's a 6 there. And then going back the other way, you can't have a 5 and an 8 because the 5 would be smaller. So that's all we can have in that one. A 3, that's going to be bigger than a 3. 4, 5, so it's got to be a 6, a 7. It's got to be smaller than that one, so it can only be, can be an 8 if that's a 9. Oh, but there's an 8 there. So that can only be a 6 or 7. It can't be a 9. Can't possibly be smaller than that one if it's a 9. So that leaves this one next. So we can have a 1, no, we can't have a 1, 2. We could have a 2 there and a 4 there. We can't have 3, 6, there's 2 3s there. So 2, 4, we can have 4, 8, and it can go either way. So that can be an 8, and that can be a 4 or an 8. That's the only options. That means that's a 4 or a 4 and a 2, or a 4 and an 8, or a 4 and an 8. So it doesn't matter what we do there. One of those is a 4, which means this one can't be a 4. That's got to be a 5, and that was an 8 to go with a 5. That one's not an 8, so you can still have that option though. And that one's going to be smaller than a 5. 1, 2, 3. It's got to be a 4. And that gives us that one's a 2, and that one's a 4. Excuse me again. A bit tickly when I talk too much. Now that's got to be 6, 7, 9. There's a 7, 9 there. Actually, that one has to be the 6. And that one's got to be a 7 or a 9. And there's... Can't have a 9 there, so that's got to be the 9, and that one's got to be the 7. And that's not a 7. Now we have another cage, 23. Those two have to add up. Let's do the 8 first. 8 from 23 is 15. So you'd have to have a 9, 6 or an 8, 7. We can't have a 9, 6 because of the 9. We can't have an 8, 7 because there's an 8 already, which means that's a 9. 9 from 23 is 14. So now we have to have, you can't have 9, 5. We can only have 8, 6 for 14. And they have to go, that 8 has to go there. And the 6 has to go there. Now a nice easy 1, 2, 3 for a 6. 1, 2. Leaves 5, 7. The 5 has to go there. And a 7 there. And back over there, so I know these ones here. What can we have here? We can have 1, 2. Can't have 3, can't have 4, can't have 8. That's all we can have there. So that one's a 1, 2 as well. And that leaves 1, 2, 3, 4, 5, 6 for up the top. Now that one's a minimum. So it's a 1, that's a 2, and that's a 1. And what have we got up here? 1, 2, 3, 4, 5, 6, 7. I think 2, 7, yes. Not as much point putting these in yet. We'll see what we can get over here. What's this one got to be? 1, 2, 3, 4. It's got to be bigger than a 6. 8, 9, it's got to be a 7. That's got, couldn't be 8, 9, so 7 was the only other option. Now what can we have in here? In this one here, can't have a 2 because there's got to be a 2 there. We can have 1, 3 or 5. 6, 7, 8, 9, that's all that's missing there. This one has to be 1, 3, 5 and an 8. And this one has to be 1, 2, 3, 4, 5, 6 and a 9. I put these ones in while I'm at, I guess. So 2, 7 looks like it goes there. 1, 2, 3, 4, 5, 9 for that one. And 1, 2, 3, 4, 5, 6 and 8 for that one. Doesn't resolve anything, but it'll make it easier later on. Excuse me, coughing. Now this one here can't be 1, 2, 3, 4. It's got to be less than a 7, so it can only be a 5 or a 6. And then what can we have here? 6 can't be 6 and 5 because that'd have to be a 2. Can't be 5 and 5 because you can't have 2 5s. So that means that one's not a 5. 6 and 3 is 9. You can have that with a 4. 6 and 1's 7. Would have to be with a 6. You can't have another 6. 5 and 3 is 8. And 5. You can't have another 5. 5 and 1's 6 and 7. That's the only possibilities there. Now now there's 1, 2, 3 there now, so that one has to be a 5. That's a big one, so that has to be an 8. That's a 9, a 5, 6, that resolves a few things. It's a 4, not a 4, not an 8. Now that's given us a 1, 3. How does that help? We can't have, that helps because look at all these 1s. We can't have a 1 there, we can't have a 1 there, we can't have a 1 there now, we can't have a 1 there. So we've got to have a 1 there. And that helps, we've got a 2 there. Excuse me. 2 there. 4. That's got to add to 13 now, so it's got to be a 9, which is 6 and 3. And that's a 1, 3, 2, 1, 4, 2. All of them resolved just about. 6 and a 7 and a 2. And now, what do we have up here? 1, 2, 3, 4, 5, 6, 7. That's a 3, 7 pair. Can't tell where they go yet. That one is 1, 2, 3, 4, 5, 6, 7. That's an 8. 1, 2, 3, 4. We need a 5 and a 9 to go in here. Obviously, the 9 has to go in the bigger square there. That's a 5. And now I guess it's just a matter of putting the numbers in all these squares and see what comes out, isn't it? That's probably the easiest, quickest way, is just to go 1, 2, 3, 4, 5, 6, 9. Anything come out of that one? Yes, there's a 9. That's a 4. That's a 6. And this one has to be a 3. It's probably not going to resolve because of that 3, 7 there. So this one's a 3, 4, 5, 6, 7, 8. And no, that didn't resolve. This one might though. 1, 2. Oh, it's another 3. It probably won't. 4, 5, 6, 7, and 9. That's not a 9. I'll go as a pair, so that did help. That's not a 7 or a 3, so that one's a 9. And this one, let's hope. Oh, hang on, there's a thing there I've missed. 4. That's got to be smaller than that, so that one has to be a 7. That will resolve the 3s for us. It's going to be a 3, a 7, 3, 5, 8, and 3. And now just these ones. 1, 2, 3. We need a 4, which has to go there. 5 has to go there. And you realise and an 8 left over. And there we go. That wasn't too bad a puzzle. Looks quite fun actually. I quite enjoyed doing those maximum minimum ones for something different. I hope you enjoyed it too. And I will see you next time.